Hello everyone, welcome back to my YouTube channel. This is Kusuma studying in Sri Venkateshwara College of Engineering, Bangalore. In this video, we will discuss about the modulation, introduction to VSB, what is VSB, generation of the VSB, advantages of the VSB and application of the VSB in television broadcasting. What is modulation? The process by which data or the information is converted into electrical or digital signals for transferring that signal over a medium is called modulation. It increases strength for maximum reach of the signals. The process of extracting information or the data from the transmitted signal is called demodulation. This picture depicts that when the low frequency signal, that is message signal, is imposed onto the high frequency signal, that is carrier signal, the resultant is the modulated signal. Introduction to VSB. The term VSB stands for vestigial sideband. It is a kind of amplitude modulation technique where a part of signal named as a vestige and it is modulated with one sideband. For the transmission, both the bands are not necessary because it is a waste. But if a single band is transmitted, then the data will be lost. Therefore, this method has developed. A VSB signal is designed like the following image. So in this picture, along with the upper sideband, a part of lower sideband is also transmitted in this technique. On either side of the VSB, the guard bands of small width is placed because to avoid the interferences. And this technique is used in the television broadcasting. Next we move on to the why VSB is preferred over SSB, that is single sideband modulation. In the case of the SSB modulation, when a sideband is passed through the filters, the bandpass filter may not work perfectly in practice. As a result of which, some of the information may get lost. Hence, to avoid this loss, a technique is chosen, which is a compromise between DSB-SC, that is double sideband suppressed carrier, and SSB, that is single sideband, called as vestigial sideband technique. The word vestige, which means a part from which the name is derived. So this is the output spectrum of the SSB signal and VSB signal. In the case of the SSB signal, either a USB signal or LSB signal is transmitted. Whereas in the case of the VSB signal, only a small amount or the vestige of the unwanted sideband will also appear along with the desired sideband. So that is known as vestigial sideband modulation. Next we move on to the generation of the VSB. Generation of the VSB SC wave is similar to the generation of the SSB SC wave. The VSB SC modulator is shown in the following figure. With the help of the product modulator, we can able to generate the DSB-SC wave and then by passing DSB-SC wave to the sideband shaping filter, we can able to generate VSB-SC wave. Generation of the VSB. The modulating signal X of t is applied to a product modulator. The output of the carrier oscillator is also applied to the other input of the product modulator. The output of the product modulator is then given by m of t is equals to x of t into c of t. Substituting for c of t, x of t is equals to vc into cos 2 pi fct. This represents a DSP-SC modulated wave. This DSP-SC signal is then applied to a sideband shaping filter. The design of this filter depends on the desired spectrum of the VSB modulated signal. This filter will pass the wanted sideband and the vestige of the unwanted sideband. Let the transfer function of the filter be h of f. Hence, the spectrum of the VSB modulated signal is given by S of f is equals to Vc by 2 into x of f minus fc plus x of f plus fc into h of f. Next, we move on to the frequencies domain description. The spectrum of the VSB-SC is shown in the below figure. In the frequency spectrum, it is assumed that the upper sideband is transmitted as it is and lower sideband is modified into vestigial sideband. Next we move on to the advantages of the VSB. Highly efficient, reduction in the bandwidth, filter design is easy as high accuracy is not needed. The transmission of the low frequency components is possible without difficulty. Possesses good phase characteristics. The main advantage of the VSB modulation is the reduction in the bandwidth. It is almost as efficient as SSB. Due to allowance of transmitting a part of the lower sideband, the constraint on the filters have been relaxed. It possesses good phase characteristics and makes the transmission of the low frequency component possible. Practical filters can be used for the partial suppression of the LSB. Next we move on to the disadvantages of the VSB. Bandwidth is more when compared to the SSB-SC wave, that is single sideband modulation. Demodulation is complex. Its bandwidth requirement is somewhat higher than that of the SSB modulation due to presence of vestige. Vestigial sideband modulation leads to a complex demodulation process at the receiver end. Next we move on to the applications of the VSB in television broadcasting. For the transmission of the television signals, VSB technique is widely used. As during transmission of the TV signals, there is a need of simultaneous transmission of both audio and video information. Since a bandwidth of the video signal is 4.2 MHz and we can already discuss in DSP-SC modulation that it requires bandwidth twice that of the message signal. Hence, in the case of the DSP system, the required bandwidth will become 8.4 MHz, that is twice the bandwidth of the video signal. Furthermore, by inserting guard band between audio and video carriers, then it leads to the some more increases in channel bandwidth and causes it to reach up to 9 MHz. Such a large bandwidth must be reduced and so VSP technique is adopted. Here we can see the spectrum of the transmission of TV signal using VSP technique in the figure shown below. This is the spectrum of the transmitted TV signal using VSP transmission. VSP technique allows the transmission of the upper sideband along with the vestige of the lower sideband. However, suppresses the remaining part. From 1.25 MHz to lower sideband 0.75 MHz vestige is transmitted and rest is suppressed. This basically simplifies the filtering requirements. Hence, by this we can reduce the bandwidth requirement to 6 MHz from 9 MHz. Guys, if you like this video, please like, share and subscribe to my YouTube channel. Thank you.